Dear students, in the class we are going to discuss Unit 1 Partial Differential Equation, Tutorial 1. See the question. Starting word PDF is available. So see the first question. So we can cut in paste there. Okay. Then paste here. We can write the solution for this. So what is the question here? Form the PDE by eliminating arbitrary constants a and b from x minus a whole square plus x minus b whole square plus z square equal to c square. Now, how to eliminate that arbitrary constants a and b? So, how many arbitrary constants are there? Two arbitrary constants a and b. We can expand it. Then this is the ruler. It's not better. Okay. Solution. How many arbitrary constants are there? A and b. How many independent variables are there? X and y are the independent variables. Then the resulting equation will be in the first order PDE. Why? If the equal number of arbitrary constant equal number of independent variables, you will get a solution in the first order. So what is given here? Write that given problem x minus a whole square plus y minus b whole square. Actually, that should be that y minus b. Yeah, otherwise we are giving us x minus a plus small correction here. Y minus b whole square plus z square equal to c square. So plus y minus b whole square plus z square equal to 1. So differentiating, this is equation number 1. Differentiating 1, that is the first step. Differentiating 1 partially with respect to x, we get, when you are differentiating 1 partially with respect to x, 2 into x minus a plus 2z dou z by dou x equal to 0. Then here the 2 we can take it outside and then 0 by 2 is 0. Then remaining is we can write as x minus a plus z into, what is dou z by dou x? Dou z by dou x is p. It is denoted by p. So z p equal to 0 here. Therefore, x minus a value is minus z. This is one result. Next we are going to differentiate 1 partially. Once again you have to differentiate 1 partially with respect to y. We get 2 into y minus b plus 2z dou z by dou q equal to 0. Sorry, dou z by dou y equal to 0, not dou q. small fraction. Tau y equal to 0. So here also that we can take it the 2 outside and then 0 by 2 equal to 0. Then we will get that y minus b plus z cube equal to 0, since we can write that tau z by tau q equal to 0. Then y minus b equal to minus z cube. This one more result here. Already we have taken that x minus a equal to minus zp. We can take it this as equation number 2. This is equation number 3. Substituting 2 and 3 in 1. Substituting 2 and 3 in 1. So what is 2 here? X minus a, and then 3 is y minus b. So substituting that x minus a whole square plus y minus b whole square is there. Already we know the value of x minus a and y minus b. Substituting in equation number 1, we get minus, the equation 1 becomes minus zp whole square plus minus zq whole square plus z square, constant value c square. So z square p square, z square q square plus z square equal to c square. Therefore, we can take it that z square outside. Then we will get that p square plus q square plus 1 equal to c square, which is a recursive. To eliminate an arbitrary constant and arbitrary function, always you have to differentiate with respect to x and y. Then you have to eliminate the arbitrary constants. As I told that in case number of arbitrary constant equal to the number of independent variables, so here two arbitrary constant, two arbitrary, independent variable is there, then you will get that resulting equation in first order. In case if you are having that more arbitrary constant, more arbitrary constant than the independent variable, you will get that resulting equation in second order. We can go for the second problem. Once again, we'll cut it and then paste here. Form the PD by eliminating the arbitrary constants A and B from second one. So, put it here. B. So this is the second question here. In the second question, we can see that form the PD by eliminating that arbitrary constant. How many arbitrary constants here? A and B. Arbitrary constants are A and B. Two arbitrary constants are there. Similarly, independent variables are x and y. Here also the two independent variables are there. So the number of arbitrary constants equal to the number of independent variables. Therefore, we will get that resulting equation in first order PD. Isn't it? Now we will solve the problem. Answer is write the solution for this. Okay. Fine. You have to differentiate with respect to x and y as usual. What is given here? Given same problem we have solved in the class also. Log a z minus 1 equal to x plus ay plus b. Okay, this is equation number 1. Then differentiate 1 partially with respect to x, then we will get it log a z minus 1. If you are differentiating that, you will get that 1 by a z minus 1. Once again, you have to differentiate this a z minus 1. You will get that a into dou z by dou x. Differentiation of 1 is 0. That is equal to differentiation of x is 1. So already we know that dou z by dou x is p. Substitute here, you will get that 1 by a z minus 1 ap equal to 1. So cross multiply this ap equal to a z minus 1, then ap plus a z equal to 1. Then you can take it that a outside, this is p plus z equal to 1. So a value is 1 by p plus z. A value is 1 by p plus z. Then this is solution number 2. Then differentiating 1 partially with respect to y, we got okay, what is the given equation here? Log a z minus 1. Log a z minus 1 is 1 by a z minus 1. Then differentiation of a z is a into dou z by dou y, and the differentiation of 1 is 0 equal to what is right hand side here, x plus ay plus b. So x plus ay means x is 0 plus a into y is 1, then differentiation of b is 0. And what do you get here? A get cancelled. So 1 by a z minus 1 can be written as, you take it cross multiple that a z minus 1 there, then we will get that dou z by dou y is q equal to 1 by a z minus 1 cross multiplication here, a z minus 1. Then we have to take it that minus 1 to that side, 1 plus q equal to a z. Then what is the value of a here? A equal to 1 plus q by z. Q by z. Is it not? So we can get it that one more result here. You can see that equation number 2 and 3, that left hand side is a. Therefore, both of them are a, equating both a here 1 by p plus z by p plus z equal to 1 plus q by z. So cross multiple this, you will get that z equal to 1 plus q into p plus z. So that is the answer is what different. So you have to simplify this. Z equal to p plus z plus qp plus z, is it not? So both the sides, sorry, p plus z plus qp plus qz. Q is it. So that ZZ can cancel. Then we will get that 0 equal to, we are taking the Q outside, P plus Q into P plus Z. Maybe the answer. Yeah, that is the answer. Third problem, this is the record partial differential equation. Then we can go for the third problem. Third problem is, let's see here. Here. Find the complete integral of PQ plus P plus Q equal to 0. Here, see that find the complete integral of PQ plus P plus Q equal to 0. Write the solution for this. See the equation. The equation contains only P and Q. So it is in the format of F of P comma Q equal to 0. It is a standard type 1. It is of standard type 1. So for this, you have to differentiate what is given here. You have to write that given PQ plus P plus Q equal to 0, which is equation number 1. How to write the answer for this? That is, you can assume that Z equal to AX plus BY plus C is the solution of equation 1, but it is not the complete integral. It is not the complete integral. What is the definition of the complete integral? The complete integral should have the equal number of arbitrary constant and equal number of independent variables. See that Z equal to Ax plus By plus C as that only 2 independent variables and then 3 arbitrary constants A, B, C. So how many independent variables are there here? X and Y, and then arbitrary constants are A, B, C. So both are not equal. Therefore, it is not the complete integral. We have to eliminate one arbitrary constant here. So our aim is to eliminate any one of the arbitrary constants. For this, you have to differentiate one with respect to, not differentiate one, differentiate two with respect to x and y. X and y. We will get that dou z by dou x equal to a, and then that means p equal to a, dou z by dou y, dou z by dou y equal to p. That means q equal to b. So if you are substituting that a and b in the given equation, this is equation number 3, substituting 3 in, not only 3, yeah, 3 in 1, we will get that what is 1 here, pq plus p plus q equal to 0. So that means AB plus A plus B equal to 0. Then what is the value of B here? If you are taking B common, A plus 1 equal to minus A. So B equal to minus A by A plus 1. That means you are expressing B as in terms of A, substituting, this is equation number 4, substituting 4 into, if you are substituting 4 into, what happen is, so what is the equation here? Equation number 2. Equation number 2 is z equal to ax plus by plus c. So in the term of b, you are substituting that a here. If you are substituting b in terms of a, what happened? Only it contain only the two arbitrary constants a and c, and then two independent variables x and y. Therefore, it is the complete integral. Now, if you substituting that b equal to minus a by a plus 1 in the equation number 2, we get that z equal to ax minus a by a plus 1 y plus c. So, which is the required to complete? Which is the required to complete integral. Now, we will see that next problem. Next problem is, see this fourth problem, root p plus root q equal to 1. What is this? Then here, then root p plus root q equal to 1. So write the solution for this. What is given here? Given is root p plus root q equal to 1. See this equation, you can see only it contains p and q. Therefore, you write the equation is of the form f of p comma q equal to 0, which is the standard type 1. It is like the previous problem. Even in the previous problem also, it is the standard type 1. This is also the standard type 1. Not standard form, standard type 1. Write it here. Standard type 1. So, how to solve this? Assume that equation number 1 z equal to ax plus by plus c is here solution of PD 1. Okay, but it is not the complete integral. That is, we can see that question here. What is the difference between last problem question and this question? Even in the last problem, find the complete integral. Okay, but here given only solve. So we have to find the complete integral and the singular integral both for this problem. Problem number 4, I think. Problem number 4. But it is not a complete integral since it contains only two independent variables and 3 arbitrary constants. So by the definition of that complete integral, the solution should have that equal number of arbitrary constant and equal number of independent variable. Therefore, we have to differentiate two partially. Differentiate two partially with respect to x and y. We get dou z by dou x equal to p. So that means equal to a. Dou z by dou y equal to b. That is equal to q, which is equation number 3. Substituting equation 3 in 1, we get that what is given equation number 1, root b plus root q equal to 1. Isn't that so? We'll get that root a plus root b equal to 1. You can write this as root b equal to 1 minus root a. Then squaring on both sides. Squaring on both sides, we will get b equal to 1 minus root a whole square. This is equation number 4. Substituting 4 in 2. If we are substituting 4 in 2, we will get that what is 2 here, z equal to ax plus by plus c. This is the equation. In the equation, you are substituting that b value. B equal to 1 minus root a whole square. Therefore, what is the answer for this? What is the complete integral here? You can write it. Complete integral is z equal to ax plus by. Is it not so? B is 1 minus root a whole square plus c, which is the required to complete. Next, we have to write that to find the singular integral. To find in the previous problem, they are mentioned that we have to find only the complete integral. So we are stop our solution up to the complete integral. But in the problem, they are giving not mentioned that you have to find the complete integral. Just they are giving the solve. So we have to find that both complete integral and the singular integral. So what is the singular? To find the singular integral, differentiate that complete integral. Underline this. To find the singular integral, differentiate the complete integral with respect to the arbitrary constants a and c and equal to equal to 0. So there are two arbitrary constants are there, a and c. If you are integrate with respect to a first, what you get? Dou z by dou x dou a equal to x plus 1 by root a whole square is there, na? So 1 minus root a whole square is there. If you are expanding this 1 by, so we have to write that dou by dou a of, just we can write dou by dou a of 1 minus root a whole square plus constant c is there. When you are differentiate this is equal to 0, leave it. So equal to 0. When you are differentiate with respect to c, what happened is dou z by dou c equal to 1. When you are equating to 0, 1 equal to 0. See, for this, you can see that 1 equal to 0 is there. The 1 equal to 0 is not possible. 1 equal to 0 is not possible. So we will get the trivial solution. Then finally we can write that there is no singular integral for this video. Write that there is no singular integral for the given partial differential equation. This is the answer for fourth problem. Now we can see that what is the answer for the fifth problem. And we have to do that this. What is fifth problem here? No, that is I think already we solved that fifth problem and fourth problem. I think I didn't solve this third problem. Okay, so take the third problem. First we need to change it. This is the fourth problem. It is not that problem. It's the fifth problem. It's the fifth problem. Change the problem number 5. Problem number 5 here. Problem number 4. And last problem is problem number 3 actually. This is the problem number 3. We'll solve that. Write the solution for this. Eliminate the arbitrary function f from the z equal to f of x square plus y square. So what is the given equation here? Given is z equal to f of x square plus y square. We have to eliminate the arbitrary function here. To eliminate that arbitrary function, differentiate with respect to x and y. Here we can see that one note, how many arbitrary functions are there? Arbitrary function is that f, only one arbitrary function, and then you will get that the resulting equation in first order PD. If only one arbitrary function is there, you will get the resulting equation in first order. In case two arbitrary function is there, you will get that resulting equation in second order. Differentiate one partially. Differentiate one partially with respect to x and y. We get dou z by dou x equal to f dash. Just you write that f dash of x square plus y square. Then you have to differentiate that x square plus y square with respect to x. So first we are differentiating that f, then we are differentiating that inside what is the function is there. So that is p equal to f dash of x square plus y square, and then what is dou by dou x of x square plus y square is 2x. This is equation number 2. If you are differentiate with respect to y, then we will get that dou z by dou y equal to f dash of x square plus y square. Then you are differentiating that x square plus y square with respect to y. So what is dou z by dou y? That is q equal to f dash of x square plus y square. Then dou by dou y of x square plus y square is 2y, which is equation number 3. To eliminate the arbitrary function, then that means we have to divide the 2 and the 3, then easily we can eliminate that arbitrary function here. 2 by 3, that implies p by q equal to f dash of x square plus y square with 2x divided by f dash of x square plus y square into 2y. So what other things are cancelled here? 2 get cancelled. This 2 and then 2 get cancelled. The remaining things are there. Then this is get cancelled. Then the remaining things we have to write the cross multiply here. P by q equal to Write one more step. P by Q equal to x by y. That implies Py equal to Qx. That means Py minus Qx equal to 0. This is the vacuum of the partial differential equation. Next part B is there. Part B, sixth problem. Up to now we have discussed that part A. First question, only one thing is here, that is x minus a whole square and x minus b, which is not x minus b, it is y minus b whole square. Please note down this, and then the remaining things we have solved. We have solved first 5 problems in that class. In the next class, we will see that the solutions of part B. Thank you. See you in the next class.